Okay, Braylon, we're going to be looking at lesson 22 together today. You're going to want to find in your packet, you're going to look for that page that you can see right here in front of you. And you see a lot of things that are already summarized for you, but I'm going to go ahead and explain those a little bit further in detail. And then once you understand them, you'll have those right there in your notes for you, which will be great. So we're going to go ahead and start off. I'm going to zoom down to the bottom here so I can get a blank page so that I can write for you here. Okay, so the first thing that we want to address are numerical equations. And numerical equations are equations that, I'm sorry, I said equation, numerical expressions. Sorry about that. A numerical expression is an expression that is made up of numbers. It is basically, as Saxon puts it, a meaningful arrangement of numerals. Okay, and so we're going to give some examples here of what that would look like. So let's just say I'm going to write 4 different little examples here. 4 is a numerical expression. 6 plus 3 is a numerical expression. We could have 4 times the quantity of 2 plus 3 as an expression. And then here's a little bit more challenging one. Okay, those are called your expressions. And then we have values for each numerical expression. For letter A, it's just simply 4. For letter B, it would be 9. For letter C, it would be, this is 5, it would be 20. And for letter D, we would have, let's see, 7 times, oh, we can actually do some canceling here. So that on the bottom here is 7, so I could just cancel those 7s out. And you would have 12. Okay, so you have your expressions and you have your values. Okay, excuse me. Then we have an algebraic expression. An algebraic expression could consist of an expression that involves just a number, but most generally you're going to see them where they have numbers and variables. So it would contain variables along with the numbers. Okay, so that's the difference there. But here's another example. So 6 is actually considered an algebraic expression. It's just the numerical part of it. Then we could have x plus 4. We could have x squared minus 6. And we could have x times x plus 4. There's 4 examples of an algebraic expression. Okay, now generally we would assign a value to the variable. So like in this case, let's just assign x the value of 3. So if x is equal to 3. So this is already done. I mean, there's no x there, so there's nothing we can do there. But we could put a 3 in for x, and our value would be 7. So I'm going to list the values here. Okay, if I put a 3 in here, we have 9 minus 6, and the value is 3. And here we would put a 3 in, and we would have 21. Okay, so you have your numerical expressions up top up here, and their values. And here we have algebraic expressions and their values. Excuse me. Okay, now let's address 22B in your book is talking about statements and sentences. So I'm just going to kind of give a little bit of an example here. In the book, they actually write this statement out. The number of peaches equals the number of apples. Seems pretty simple. Okay, how would I write that? I would look at this as we have number of peaches, number of apples, and then this equals here. We could make a sentence out of that, which we would call a statement or an equation. So we could write the number of peaches equals the number of apples. If the statement said the number of peaches is not equal to the number of apples, well, then we would write this, not equal. If it said the number of peaches is greater than the number of apples, then we would use the greater than sign. And then also we could consider that the number of peaches is less than the number of apples, and we would write the less than sign. Okay, this is called an equation. That's pretty simple because when you kind of see the equals in there. Okay, an equation is something that is set equal to each other. None of these are set as being equal, so we call these inequalities. Okay, and that pretty much sums that up. Let's look at 22C. 22C in our books, we're going to talk about conditional equations. Okay, so let's say we're going to look at a few different statements here. So if I have 4 equals 3 plus 1, is that a true statement? Yes, it is, because 4 equals 4. What about if I have 4 plus x equals 2 plus 2 plus x? And I say, let's test a couple of values for x to see if this can make a true statement here. So we're going to put in a -3, and then we're going to test it again with a +7. So let's put that -3 in there. So if I had 4 plus a -3 equals 2 plus 2 plus a -3, you can probably see where this is going. I would have 1 here, and I would have 1 here. So actually, that is true. Let's try the 7. 4 plus 7 equals 2 plus 2 plus 7. 11 equals 11. True. So 7 also makes this equation true, or satisfies the equation is what we might call it. Letter C, if you see something that looks like that, well, that's not true, is it? We call that a false statement. 4 does not equal 6. Let's look at D. 4 plus x equals 6 plus x. And let's say we're going to test this with 2 different numbers for the variable x. So we're going to test it with a -3, and then we're going to test it with a 7 again. So let's try this. So 4 plus a -3 equals 6 plus a -3. I have 1 equals 3. Well, that is a false equation, isn't it? That's not true. That didn't end up being true. So -3 does not satisfy the equation. Let's try +7. 4 plus 7 equals 6 plus 7. 11 equals 13. No, it doesn't. So that's false. Okay, so neither one of those actually satisfy the equation. So that is not a true statement. That is a false statement or a false equation. Let's look at one more. Let's say we have x plus 4 equals 8. And I'm going to use x is going to be equal to -2. We're going to test that, and we're going to test it when it's equal to 4. So we have -2 in for x, plus 4 equals 8. This is 4. -2 plus 4 is actually 2 equals 8. That is false, isn't it? So -2 does not satisfy the equation. Let's try the 4. 4 plus 4 equals 8. 8 equals 8. That is true, isn't it? Okay, so when you're testing different numbers to see if they satisfy an equation, if they don't both satisfy the equation, then we call this a conditional equation. Now let me back up for just 1 second here. So let's keep in mind here, what we just did, we substituted all these different values into these different equations. So when a replacement value does make an equation true, remember this, it satisfies the equation. And when that happens, those solutions that work, or those numbers that we filled in for x that work, are called solutions. So like up here, where we had this equation and we had -3 and -7 both worked and satisfied that equation, we call those solutions to the equation, or sometimes they're called roots to the equation. Okay, so let's look at another one of the ones. So this one was false. Let's look at D. Both of those were false, weren't they? False and false. Neither one of those worked on that equation. And then on this equation, unlike B, where we had two solutions working, we tried two different numbers here. We tried x minus 2, x is equal to negative 2, and x is equal to 4. And when we did that, negative 2 did not satisfy the equation, but 4 did. And that's why it's called a conditional equation, because it does not every value that you stick in for x may work. That is a conditional equation. Okay, so let's do some examples here together now. 22(1) in your book here, we have the question, does negative 2 or positive 5 satisfy the equation x squared equals negative 5, sorry about that, negative 5x minus 6. Okay, so that's the question. All right, so what we're going to do is we're going to set this equation up 2 different times and test both of those values for x. So the first one I'm going to do is I'm going to plug in a negative 2. So we have negative 2 squared equals negative 5 times negative 2 minus 6. We have 4 equals 10 minus 6. 4 equals 4. True. Okay, so we know that negative 2 is a solution or a root to the problem. It satisfies the equation. Now let's try the other value we are to plug in for x, which is a positive 5. So we put 5 squared equals negative 5 times 5 minus 6. 25 equals negative 25 minus 6. And we end up with, what is this over here, negative 31? 25 equals negative 31? Nope, don't think so. That is a false equation. So positive 5 is not a solution or a root to this problem. Only negative 2 is. All right, let's try 22.2 in your book. So we are given x squared minus 3x equals 10. We are being asked if negative 2 or positive 5, are they roots of the equation? So let's check it out. And remember, roots are the same as solutions. And quite frankly, you're going to hear an algebra teacher will most generally use the term solutions, but I'm addressing roots because sometimes I notice in this lesson they're asking for the roots. So just remember they mean the same thing. All right, so we're going to put a negative 2 in for x. We already kind of did that, didn't we? Oh, no, this is a different equation. Minus 3 times a negative 2 equals 10. So we have 4 plus 6 equals 10. Ah, that is true, isn't it? Okay, so negative 2 is a root of the equation. Let's try the next value. We're going to put in a positive 5 for x. So we put 5 squared minus 3 times 5 equals 10. We have 25 minus 15 equals 10. And 10 equals 10. Yes, that is also true. So both of these solutions, negative 2 and 5, those numbers, both of those values are solutions or roots that satisfy this equation. Okay, and that sums up the entire lesson for today as far as the teaching. So let's go back up. I'm going to scroll way up. Watch your eyes. I'm going to scroll way up to the top here where lesson 2 begins. Or lesson 22 rather. All right, so let's look here. So now you see there's numerical expressions are here with their description of what they are. They are expressions that contain numbers and operations, like you see the examples there. An algebraic expression most generally is going to contain a variable as well as a number. These are not set up as equations. They call them expressions because remember, it's just an arrangement, a meaningful arrangement of numbers making a numerical or algebraic expression. Over here, you see the notes for the solution to an equation. It's a value for a variable that makes an equation true. So we have 2 plus x equals 4 right here, and here is the value for the variable. We're going to call we're going to assign 2 to that x. You solve it and see if 2 is actually a solution to the problem, in which it is. And then over here, of course, is another equation with a value for the variable a. You plug that in, you find out that it does work out. At the end, 23 equals 23, so it checks out to be a solution to the equation. There are 2 practice problems that you can grab from page 97. It's A and B. I'm going to do them here. If you want to pause the video to try those practice problems yourself, go ahead and pause it right now and then come back and check your answers and see how you did. Okay, so we have x minus 2 equals 0. We want to test to see if negative 2 and 2, if they will satisfy this equation. So we're going to plug it in 2 times. So I'm going to put a little line right here and go x minus 2. We'll put this here. X minus 2 equals 0. I'm going to plug in negative 2 for x, and I end up with negative 4 equals 0. And that is not a true statement, so that is false. So negative 2 does not work. Let's try 2. So we have x minus 2 equals 0. I'm going to put a 2 in there. 2 minus 2 equals 0. 0 equals 0. That is a true equation. So 2 is a solution to the equation x minus 2 equals 0. When you plug 2 in, it makes a true statement, causing that solution to be considered as such. Letter B, we have x squared plus 7x equals a negative 10. We're going to test this out on the 2 numbers that they are giving to us, which is a negative 2 and a negative 5. So let's test those 2 numbers with this equation. So I'm going to plug in a negative 2. I'm going to scribble it a little bit bigger here. Negative 2 squared plus 7 times a negative 2 equals negative 10. I have 4 minus 14 equals a negative 10. Negative 10 equals negative 10 makes this a true statement. So we see that negative 2 is a solution to this, or a root. The question is actually asking on letter B if negative 2 or negative 5 are roots of the equation. So negative 2 is a root. Now let's test negative 5. Negative 5 squared plus 7 times negative 5 equals negative 10. We have 25 minus 35 equals negative 10. And if I do the math there, negative 10 does equal negative 10. And so therefore, that makes a true statement as well. So negative 5 is also a root or a solution to that equation. There's your practice problems. You can go ahead and work through the lesson problems that are assigned for lesson 22. If you have questions, let me know. Thanks for watching. Talk soon. Bye-bye.